particle moving in a straight line has an acceleration of 3t minus 4 meters per second squared at time t seconds. The particle initially has a displacement of 1 meter from a fixed point O and a velocity of 2 meters per second. We want to find when the velocity of the particle is 0 and the displacement of the particle when t is 3. Now, displacement, velocity, acceleration, we know that we differentiate when we're going that way, so we integrate going this way. So v is going to be the integral of a dt. So that's equal to the integral of 3t minus 4 dt, which is 3t squared over 2 minus 4t plus a constant. Now we know that v is 2 when t is 0. So v equals 2 when t equals 0. If we substituted those in, that means that c equals 2. So v is equal to 3t squared over 2 minus 4t plus 2. Now, if v equals 0, 3t squared over 2 minus 4t plus 2 is equal to 0. So 3t squared minus 8t plus 4 is equal to 0. Let's see if we can factorize that. So 3t and t. If we have 2 and 2, and those are both minuses, well, that does the trick. So we get t is equal to 2/3 of a second, or t equals 2 seconds. Now, in part B we want displacement. So that's going to be the integral of velocity. So that's the integral of 3t squared over 2 minus 4t plus 2. So that's going to be 3t cubed over 6, and we can simplify that to t cubed over 2 minus 4t squared over 2, so that's minus 2t squared, plus 2t plus a constant. But we know that x equals 1 when t not x, equals 0. And that means that c equals 1. If we just substitute in, we can see that's the case. So x is equal to t cubed over 2 minus 2t squared plus 2t plus 1, and we want x of 3. And that's going to be 27 over 2, take away 18, add 6, add 1. Let's just calculate that. So we've got 27 over 2 minus 18, add 6, add 1, and that is 2.5 meters.